Alright, so chapter 5, section 2, we're continuing with what we did in 5.1, but now we're going to look at some properties of exponents and radicals. So we're still dealing a lot with radicals and exponents. Now we're going to see what all we can do with them. So these are a list of properties of rational exponents. First one is our product of powers. If we have two numbers with the same base, so they have to have the same base, we can combine them to 1 by just adding their exponents. So if we have a to the nth power times a to the nth power, it becomes a to the n plus nth power. So we get rid of one of the a's and just add the two exponents together. We can do this when multiplying and when they have the same base. Next, we have the power of a power. So if we have a number with an exponent and that with another exponent, we can combine the two exponents by multiplying them together. So an exponent raised to an exponent, we multiply. The product of a power, if we have two numbers that are multiplied together to the same exponent, we can distribute this exponent to both things on the inside. So it would become a to the nth power times b to the nth power. A negative exponent changes into a fraction, so it becomes 1 over whatever we had before, but we get rid of that negative. If we have a negative on the bottom, it moves it to the top of the fraction. So if it's on the top, we move it to the bottom. If it's on the bottom, we move it to the top. There'll be a couple examples in the homework where you have a negative on the bottom, so that would change it to a whole number just by moving it to the top. The 0 exponent, anything raised to the power of 0 is 1. You'll see this quite a bit. Anything raised to the power of 0 is 1. Next, we have the quotient of powers. So kind of similar to the product of powers, but when we're dividing, we can combine them together and subtract the two exponents. So when multiplying, we add them together. When dividing, we subtract. And notice how we go from having two a's to just one a, but we combine the two exponents by subtracting. And then lastly, we have the power of a quotient. Same thing, the power of multiplying, power of a product. We distribute the exponent to both things on the inside. So it would be a to the power of m divided by b to the power of m. So now we're going to take all of these properties that we have and apply them to our problems on the next slide. Any questions before we get started? All right, let's go. So looking at example 1a, we see that these have the same base. So how can we combine these two together? Casey? We add the exponent. So we have 7 to the power of 1/4 plus 1/2. Now how do we add 1/4 plus 1/2? What do we need to add fractions? Yes? We need the same denominator. So how can we get 2 to be a 4? Awesome. We multiply the top and the bottom of this fraction by 2. So it becomes 2 over 4. So when adding fractions, we need our denominators to be the same. So now we're just adding 1/4 plus 2/4. What does that give us? 3/4. So we have 7 to the 3/4 power. We're just going to leave our answer like this. Let's look at B. Inside of our parentheses, can we combine these two terms together? Why not? We can't combine them because they don't have the same base. But can we still simplify this? Well, can we do that with that exponent on the outside? Distribute it. So we're going to distribute it to that 6 to the 1/2 and the 4 to the 1/3. So we have 6 to the 1/2 squared times 4 to the 1/3 squared. Now, how can we combine these two exponents together? What do we do when we have a power raised to a power? Multiply. So we have 6 to the 1/2 times 2. What's 1/2 times 2? 1. So it would just be 6 to the power of 1. We don't have to write that 1 because 6 to the power of 1 is just 6. So we don't have to write it. We can get rid of it. It's just 6. Now we're going to do the same thing with the 4 to the 1/3. So how do we combine these two powers? Multiply. So what is 1/3 times 2? 2/3. Now just a little refresher on algebra. When multiplying a fraction and a whole number, so let's say we have 2 times 1/2. 2 is technically 2 over 1. We just multiply the tops together and the bottoms together. So we multiply straight across. So this would become 2 over 2, which simplifies to 1. So that's how we got that 1 here. And then we do the same thing with the other one. We have 1/2 times 2 over 1, or 1/3 times 2 over 1. Multiply the tops together, multiply the bottoms together, 2/3. If you can see it, you don't have to work this out. Most people can just see how to multiply these fractions, but if it helps you write them out, you just multiply the tops, multiply the bottoms. Multiplying fractions is different than adding and subtracting fractions. So make sure you know how to do both of them. All right, let's look at C. So we have 4 to the 5th power times 3 to the 5th power to the power of negative 1/5. Can we combine the inside here together? No, because they have different bases. But what do we do with this negative 1/5 outside? What can we do with that? Distribute it. So just like the last one, we need to distribute it to the 4 to the 5th power and the 3 to the 5th power. So we have 4 to the 5th power to the negative 1/5 power times 3 to the 5th power to the negative 1/5 power. All right, so how do we simplify a power raised to a power? Multiply. So what's 5 times negative 1/5? Negative 1. So we have 4 to the power of negative 1. And then what's 3 to the power of 5 to the power of negative 1/5? What do we do with our exponents? Multiply. So it's 5 times negative 1/5. Negative 1. So 3 to the power of negative 1. Now when we have negatives in our exponents, what does that change this to? A fraction. So we have 1 over 4 times 1 over 3. Now I got rid of that power because technically when you bring it to the bottom, it becomes positive. So it would be 4 to the power of 1, but we don't have to write the power of 1. So it's just 4. Can we simplify this? Yeah, we're just multiplying fractions. We multiply tops together, multiply the bottoms together. So we have 1 over 12. That's our answer. All right, let's look at D. Any questions on that one before we move on? All right, D. Can we combine this 5 and 5 1/3 together? Does that 5 on top have an exponent? Yes, what's the exponent? 1. So now we have two numbers with the same base that we're dividing. So how can we combine them? How can we combine their exponents? Perfect. We combine them by subtracting their exponents. So we have 1 minus 1/3. Now how can we subtract 1 minus 1/3? What do we need to subtract decimals? Subtract fractions. I'm sorry. What do we need to do to subtract fractions? Perfect. We're going to change this 1 to a 3/3 because we need the denominators to be the same. So we have 5 to the power of, what is 3/3 minus 1/3? 2/3. So 5 to the power of 2/3. All right, let's look at E. So what should we do first here? Distribute the 2. So we got to distribute it to the top and to the bottom. So you have 42. What's 2 times 1/3? 2/3 over 6. What's 2 times 1/3? 2/3. Now we're going to see this a little bit more on like the 5th slide, but when our exponents are the same, we can combine them to 1. So we can change this to 42 over 6 to the power of 2/3. Because just like how we distributed this 2 to both of them, we can distribute this 2/3 to both of them and get this. So we kind of just went a step backwards and pulled it outside. Can we simplify 42 over 6, the inside of our parentheses here? 7 over 1, so just 7. So 7 to the power of 2/3. Good question. When the bases are the same and you're combining the exponents, you get rid of one of the bases and just add the 2 exponents together. So if you go back to slide 2 with all of our properties on it, we combine the 2 of the same base to just 1 and add the exponents. So we don't multiply the bases together. It just stays as the same.
Okay, thank you.
You're welcome. All right, let's look at 2. What do we do here? Awesome. This 3 on top has a power of 1, so we can combine them by subtracting. So we have 3 to the power of 1 minus 1/4. How can we subtract our fraction? Perfect. So this becomes 4 over 4. Anybody? Number 2. 3 to the 3/4. Perfect. All we did was subtract. Let's look at number 3. What should we do first? Distribute the 3. So we have 20. What's our exponent on 20 going to be? 3/2. And then 5. What's our exponent on 5 going to be? 3/2. Can we simplify this anymore?
Yeah.
What can we do?
We can take out the 3/2 and put it on the outside.
We can take out the 3/2, put it on the outside. So 20 over 5, and that 3/2 goes on the outside. Can we simplify 20 over 5?
Yeah.
To what? 4. 4 and 3/2. Alright, let's look at 4. What should we do here? Can we combine the inside together? Nope, because they're different bases, so we cannot combine. Is there anything we can do? Distribute the 3. So what operation are we performing when we distribute the 3? Are we adding them together, multiplying, subtracting? Multiplying. So we have 5. What's 1/3 times 3? 1. Because it becomes 3 over 3, which simplifies to 1. We don't even need to write it if it's 1. And then what is 1/4 times 3? 3/4. So our answer is 5 times 7 to the 3/4. Any questions on this part? All right, we have one last thing we're going to go over for today. So we have more properties to simplify our exponents. We have the products property. So if we have two numbers under the same radical, we can split them up and keep that same radical that we have, but just break them up into 2. This works both ways. So if we have two numbers under the same exponent, we can just combine them by whatever operations happening in the middle under one radical. And then the same thing works for division. So if we have a division under one radical, we can break it up into 2 separate radicals, but still keep that same operation, which is division here. So we actually did this quotient property in 2 of our examples on the slides before, where we had the same exponent and we combined them together. So let's look at our examples. So example 2a. How can we simplify this? We have the same radical here, that same index. So what can we do to simplify? We can multiply them. So we combine them together under one radical, and it is going to be 12 times 18. What is 12 times 18?
216.
Now let's see if we can simplify the cubed root of 216. What are our factors of 216? I think 2 and 72. No, 2 and 108. 6 and 36 works for sure. Also, we just multiplied 12 and 18, so 12 and 18 are factors. But 6 and 36 works. What does 36 break up into? Six and 6. We're circling groups of how many? 3. So we can circle all 3 of our 6's. So what do we get as our answer? 6. Is it a positive 6 or negative 6? Or both? Positive. Since it's odd, we only have one answer, and 216 was positive, so 6 is positive. Let's look at B. How can we simplify this? Put it under the same radical. So since these are the same, we just combine the insides together. So we have 4 radical 80 over 5. What's 80 divided by 5? 16. Let's see if we can simplify the 4th root of 16. So what are some factors of 16? 4 and 4. What are factors of 4? 2 and 2, and 2 and 2. We're circling groups of how many here? 4. So we circle all 4 of our 2's. So a 2 comes out. Is our answer positive, negative, or both? Both. Because our exponent is even, we have 2 answers. So it's the positive and negative 2. Because our index is even. That's why. So that 4 out front makes it a positive or negative 2. Any questions on this? This is where we're going to stop for today. We're going to finish the rest on Thursday and Friday. So we're splitting this section up into 3 sections. So this is part 1.